Okay, moving on to the rear axle then. Starting at this level with the axle shell, I've done exactly the same as what I did with the front axle, and that was to cut away the half shaft housings and cut down the half shafts as well. So one of the major changes that I've got to do at this level is to extend the pinion shaft. So the pinion shaft, this is the input shaft into the differential. I needed to extend it further along and extend through to pick up the drive shaft, which will eventually drive the front axle, so coupling the two axles together. So what I did is used a piece of 5mm brass, bored a 1.6mm thread inside. No, amend that, that's a 2mm, so it's an M2 thread, and then file down some flats, 2 flats on the end of the shaft, and transferred the gear over. So that's what I've done so far. So I'm now ready to build this up. I've already completed the differential unit, so that's all moving nicely and greased up, silicone grease. The other thing I've done is I've drilled out the front holes of the diff housing, and I shall be using those to put in some 4mm spacers. The two halves are held together by M2.5x10 socket head screws. I've installed 4mm standoffs, and they're 2.5mm threaded. So the next thing to look at would be the bracket. So this bracket houses the steering motor, which we'll be fitting later on, recessed holes that are recessed to sit on the axles, and they're screwed on using 4 M3x8 screws. So they're 8mm M3s, socket head, so that's the hex socket type. So 4 of those on there. Just a quick look, these holes in the side, there's 2 that side, 2 the other side. This will actually mount this frame and axle complete into the main chassis frame. There's a couple of little extra pieces on here, and they will mount, or they will hold, the motor driver circuit boards. So this is a little N20 motor, and it's got a epicyclic reduction gear system on it, so it's reducing the output shaft speed down to, I think it's around about 100-150, but that's a bit of guesswork really. So that will be mounted in a bracket, so the motor will be push fit into there. This will be mounted on the front of the axle. I've also got a bearing to fit in, that's a 5mm bearing, and that supports the output shaft of that. The next thing was to get an endless belt, G2 timing belt, and this is the smallest I could get hold of. It's 100 and it's a 2 GT, so it's a 6mm timing belt, 6mm wide. So going by that, the next thing I had to do was to make up a belt tensioner. So I've made a little bracket that fits onto this, and I can use it as a tensioner to tension up keep the belt in tension. So I should be using some of these, which is, I believe, 12mm GT2 timing gear. They're common on use on 3D printers and things like that, so you can buy them off the shelf. But I've had to modify mine slightly, because although I've got the extended 5mm shaft, this one will fit directly on there, which is good. But the motor is a 3mm D-shaped shaft. So I've had to make a 5mm down to 3mm brass bush to fit into one of these standard 5mm gears, and I've shaved it down as well, because the motor, the original shoulder houses 2 grub screws to lock it onto the shaft, and I'm running out of room to fit one of these on the end of that, plus a bearing. So what I've done is I've cut down or shaved down the face to do away with the grub screw fixings, and I've drilled and threaded a 2mm, an M2 thread that sinks into the bottom of the gear teeth, and it runs through right through to the center. So that means that I can lock this gear onto this D-shaped shaft by the M2 grub screw. So when that's locked on, the head of the grub screw is below the toothed belt, so it won't interrupt the running of the belt on the gear. So the first thing I'm going to do is to install the bearing into the housing. Then we can fit the motor into the housing as well. Fit this bracket on first, then screw that to that. Okay, so I've push fitted the bearing in there, so that's a ID3 OD8 and it's a depth of 3mm. So that will take the motor now, so I can actually line that up so that the terminals are poking out the right hand side as we look at it, somewhere around about there, and I can push that in, making sure that the shaft is passing through the bearing at the front. That's it, and he's gone in with a nice click, which meant that he's sat all the way home. So I've already screwed the bracket on to save a bit of time, so that's held on by 4 M3 bolts, set screws, and they're 8mm long. So this bracket I should be using again. This is the housing for the steering motor, and also the little brackets there hold the motor driver boards in situ, and then these holes here are the securing bolts to secure it to the main chassis. I can attach the bracket to there, so I'll put two countersunk. These are 2.5mm M2.5, so I've got the two countersunk screw heads in there. So I've got this bracket and the motor bolted onto the front of the axle. The other two screw holes will be used in conjunction with the timing belt tensioner pulley, but I can put the standard timing belt thing on and lock it to the shaft via the two grub screws. Now the other one, we'll see how much of the motor output shaft is protruding through, and you can see that the gear is a little bit wider, so I can butt that up now. So we've got the two gears now locked onto their appropriate shafts. The idler is supported on a M2 screw, M2 by 16 I believe. So this is a little idler wheel, and inside is two ball bearings, so two ball bearing bearings, and they're ID 2mm, OD 5mm, and they're 2mm, no, amend that, 3mm wide. So it's supported by an inner bearing and an outer bearing to hold that steel. So this is the adjustable slide, so it's minimum and maximum. So all we've got to do now is push that into the minimum, and we can feed the belt over. So we'll do that. So feed that over the two pulleys, feed that around the belt idler, and then we can tension that up. I'm going to go too mad with it, just enough for it to stop it jumping off the teeth. So I'll tension that up and then tighten these two screws up as well. So we now got the belt on, tensioned up, so it's all ready for a test. So yeah, let's give it a go. So that's one way, that looks like forwards, yep. So let's reverse it a minute. So that's reverse, I believe, yeah, looking at it. So that's what the setup's going to be.